The length of a rectangle is increasing at a rate of 8 centimeters per second, and its width is increasing at the rate of 3 centimeters per second. So we got a rectangle here. Let's say length is x and width is y. Length is increasing at the rate of 8 and width is increasing at the rate of 3 centimeters per second. When the length is 20 and the width is 10, how fast is the area of the rectangle increasing? So how fast is the area? So we have area, so the rate of change of area is what? At the moment when the length is 20 and width is 10. Okay, so we have this situation. Now A is changing because x and y are changing. So we need to first write down the relationship between this area in terms of x and y. So that's pretty much the formula. A equals x times y. In this question, x is changing because we have the rate. Y is also changing. So when we differentiate both sides with respect to time, in the right side we must use the product rule. Because we have product and both are variables. So let's find derivatives of both sides with respect to time t. That's the dA over dt equals, using the product rule, we find the derivative of first dx over dt, leave y alone, plus take the derivative of y, leave x alone. So this is how we use the product rule. Now plug in the given numbers and find the unknown. dA over dt is what we are looking for, so just that. Dx over dt is 8 times y is at the moment when y is 10, plus dy over dt is 3 times x is 20. 80 plus 60, so 140, and this is area, so centimeter square per second. Okay, number 5, a cylindrical tank, something like this, with radius 5 meters. So radius is given. Okay, radius is 5, looks like the fixed radius, is being filled with water at the rate of 3 meter cube per minute. So this is meter cube means volume. Okay, cubic meters means volume. So water, so the volume dV over dt, the rate of change of volume is 3 meter cube per minute. Okay, so per minute or per second, per hour means rate. So meter cube, that's why volume. So dV over dt is 3. Now we need to determine how fast is the height of the water increasing. So this is height when water is being filled. This is increasing. So dH over dt. So how fast or how slow, in both cases, that's the rate. Height of the water increasing. So that's the question. So in this case, R is fixed. Okay, radius is not changing, and that's the obvious case here. Just the water is rising here. That means water is being filled at the rate of this. And now we need to determine how fast is the height increasing. So we have volume of water, volume V, and H. So we need to write down the formula of V in terms of H. So for a cylinder, so volume is given by, it's always the area of base times height. So the base is circle and area is pi r squared and height is H. So the volume of a cylinder is pi r squared H. Okay, but r is given 5, so we want to write that. So this V is in fact 5 squared 25 pi H. Now we take derivatives of both sides with respect to time t. That gives us dV over dt equals 25 pi dH over dt. Let's plug in the given and find the unknown. dV over dt is given 3 equals 25 pi and dH over dt is what we are looking for. Now we want to isolate this, for we need to divide both sides by 25 pi, so that implies dH over dt equals 3 over 25 pi, and that's it. Don't go for decimals. Now we need to put correct units. So this is rate of change of height, so height will be meters, in this case meters per minute. Okay, final. That's final for number 5. Let's do number 6 as well. The radius of a sphere. So we got a sphere, the radius is increasing, so dr over dt, increasing, decreasing means rate, at the rate of 4 millimeters per second. How fast is the volume increasing? So volume increasing means the rate of change of volume of this sphere. dV over dt is what? When the diameter, oh, it's given radius as a diameter, so diameter is 80, means radius is half, so that's 40 millimeters. So dV over dt equals what? When the diameter, because I want to write in terms of radius, because the radius change, rate of change of radius is given here. So at the moment when radius is 40 millimeters, okay, this is 40. Now we need to write down the relationship between volume and this radius. So what is volume of a sphere? Formula. So volume is given by 4/3 pi r cubed. 4/3 and pi are constants, so collectively constant. Now let's find the derivative of both sides with respect to time t. That gives us dV over dt equals 4/3 pi is just constant times, now derivative of r cube is 3r squared r prime, which is dr over dt. Now we can simplify. 3 on the top and bottom can be cancelled, so that gives us dV over dt equals 4 pi r squared dr over dt. Now let's plug in and find the unknown. dV over dt is being asked, so now dV over dt equals 4 pi r squared. So 4 pi r is 40 squared times dr over dt is 4. Okay, this is now 1600 and another 16,25600. Okay, I believe that's true, and pi. That many volume means now is millimeters, so millimeters cubic millimeters per second. Okay, final